So we think about hydrogen and oxygen. This was also part of my thesis work, where I didn't just collect, you're not going to go into a grocery store and just buy ground beef. You're going to buy chicken and eggs and pork and anything else you can think of. So this is just showing you that there's some nice variations between hydrogen and oxygen with the correct non-exchangeable label here on the graph. And so we can really start going after some of this origin type investigations with lots of different meats in our diets potentially. I just happen to start with ground beef because, like I said, it tends to be in our diets pretty frequently. Okay, so to sort of sum up what we can do with animals and isotope analysis in this food forensics world, we can ask questions about what the animal was eating and where it was drinking. If you've seen the forensics lecture, or if you know anything about some of the forensics work we've done, humans are animals too, of course, and so this has some forensics applications to it. Who were you? What were you drinking? What were you eating prior to your death or before the collection of a tissue? Can we reconstruct something about your history? Where was the animal raised? Am I really buying local? And then I'll move on to some nitrogen data just because it's pretty cool and hey, why not? I get to talk at you for an hour. So this is the McDonald's hamburgers from that previous data set, the supermarket ground beef, and some chicken, looking at nitrogen isotope ratios. And this was a big stacked graph that of course I couldn't fit. So here's your scale. We're going from about 1 to +8 for delta 15N. And you can see all of the burgers are fitting a fairly small range, but it's actually a higher, they look like they're at a higher trophic level than chickens. Any ideas why? We probably don't have carnivorous cows anymore. We did for a while. Anyone know what's going on with these guys? Why we're seeing some higher delta 15N values? Yeah?
One's eating C3 plants, the other C4.
These are actually, they're all mixed. We saw a fairly wide variety. I didn't show the carbon data for the chickens, but this is probably supplements in the diet. So in industrial agriculture, you typically give beef cows nitrogen. It used to be that they would give beef cows other beef cows, and that's where mad cow came from. Now they just feed beef cows chicken waste. So there you go. That's why they look like they're a trophic level higher. Yeah. Yum, right? Okay. All right, talking about some plant-based foods. We good on the meats so far? Okay, plant-based foods. You guys probably saw this in Jim's forensics lecture yesterday. Yes, some of you? So this is a high school science fair project that his son did, one of his sons did, where they looked at carbon isotope ratios of jams and jellies, which should be mostly made of fruits, C3 plants. And what they found is that most of them looked like C4 plants. So basically, when you're eating a lot of jam and jelly, especially in the United States, you're eating corn syrup or cane sugar that a strawberry was dipped into, and that's about it. So you're just spreading solid sugar on your toast. Delicious. This is the same sort of idea looking at the carbon isotope ratios of honey. This is honey being imported into the United States back in the late 80s and early 90s. And so you can see we're looking at delta 13C values here of honey, and honey is made by bees that are visiting flowering plants. Most of those flowering plants are C3 plants. But we're getting some honey that's got a pretty C4 signal in it. What is this? It's not honey, I can tell you that. It's basically doctored up cane sugar or corn syrup. And so what actually happened is that the United States, this was just an example that was being imported from China, they set a limit. They said if you have a carbon isotope ratio of greater than -23.5, you're not real honey and you cannot come into the United States. So this is what the case was. The top panel is what it looked like, what the honey looked like coming from China prior to that cutoff. And then as soon as that cutoff was implemented, this was all of the honey coming out of China. So it really started as a good screening tool for saying you're actually getting honey. And then of course what happened? Oh, well, we'll just use beet sugar instead, which is a C3 plant. So it became an arms race as to how we can use some of these isotopes as screening tools. Nitrogen and plant world, well, there's a sort of this, everyone really would love to be able to use delta 15N values as an organic screen, as an organic, can we verify the organic production of a plant by using delta 15N values? And the idea from this comes behind the fact that if you look at nitrogen in fertilizers that are produced synthetically, they all start with atmospheric nitrogen as the nitrogen donor, and so they typically have delta 15N values that sit right around 0 per mil. When we get into the organic fertilizer world, things that come from plants and animals, you tend to get higher and higher delta 15N values because you're going up a trophic level, okay? Or levels. So the idea was, can we use this delta 15N values as a way to double check that you really are organic? This was a group project that I did with an organic gardening class here on campus a few years ago. So we had the students go around and collect leafy greens. So they got things that were grown conventionally, so they're just from the supermarket, things that they either grew themselves or bought locally at the farmers markets, and then things that they bought at the supermarkets that were labeled as organic and so were much more expensive. And these are the delta 15N values. And yes, those are plus 25, which is enormous. There's a lot of fertilizer organic fertilizer being added to these plants. So that's just sort of one way to look at it, and then you can see it split out in these box plots. So it works, the organic delta 15N question works well in some cases, but it's not perfect for all organic plants. Questions on plants? Which is the smallest section. Jim is horrified because he's a plant guy. Okay, beverages. The other big one. All right, so you guys have seen stuff like this before. This is hydrogen and oxygen of tap waters from around the world. They typically fit the global meteoric water line, right? Great, science works. Here's bottled water. Again, most bottled waters fit the global meteoric water line, and then we have some oddball groups here. We start seeing things sort of fall off that relationship. Any idea what could be going on here? Yeah, they're probably using evaporated sources, so reservoirs or some sort of storage container, and then they're filtering it and selling it back to you as this, ultra purified water, but it came from some tap water reservoir. Is anyone drinking a Dasani or an Aquafina right now? That's filtered tap water that the Coca-Cola or Pepsi companies are taking and filtering and selling back to you for more per gallon than you pay for gasoline. So just be aware of that. Okay, so this is, again, I'm going around on my thesis road trips. I'm going to the grocery store and buying the most random shopping lists full of soda and beer and juice and 16th pounds of ground beef. Weirdest cookout you can imagine. Come back, measure the water in these beverages, compare it to the global meteoric water line, and most things fit except my juices, which is good. Why? Do we not want the juices on the global meteoric water line? They'd be mostly tap water if they would not be fresh squeezed. And you'll see an example of that where we double checked somebody in a little bit. So the idea is, well, if everything's fitting sort of this global meteoric water line and these water patterns are fitting, can we make a whole series of isoscapes for different beverages? And Jason West, who I think most of you met last week, yes, did just that. Back in 2007, he published a wine isoscape for the west coast of the United States. So you could verify the vintage and claim about where that wine came from by measuring the isotope ratios in the water from that wine. This is a big effort in Europe, actually. There's an international wine database, and if you want to produce a wine and sell it in the EU and then export it, you must submit a sample for testing. And isotope testing is one of those tests, plus glycerol levels and elemental concentrations and a whole suite, like the BRICS levels and things. And this was published a couple of years ago, an Alcoscape. So this is looking at beers. They were all purchased in Australia here, but they came from around the world, and this is sort of where they claim to have come from, shown the sort of color coordination about what the oxygen isotopic composition of the water in that beer sample was. So there's some work going on to sort of verify these alcoholic drinks using hydrogen and oxygen isotopes. But sometimes it reveals some really interesting features about beer production. So these are all samples of Coors beer, so not Coors Light, but just Coors. The oxygen isotopic composition of water extracted from them, these were bought in different locations around the Intermountain West. You can see some very different values here, pretty dramatic differences between each of the samples. This is the tap water for Denver, the tap water for, if we just consider all Rocky Mountain tap waters that we've ever collected. And why are we specifically pointing out Denver and the Rocky Mountains? Well, this is the claim that Miller Coors makes on their website, that all of their beer is stubbornly brewed in the same Golden, Colorado brewery with 100% Rocky Mountain water. So, there you go. So that's sort of the beer story. So, think about what we can do with hydrogen and oxygen in beverages. We can ask questions about where our bottled water is coming from. You guys have been using Evian, hopefully. Most of you have been using Evian as a standard reference material in the lab because it always looks like it comes from the same place isotopically. We'll get an answer to this on Friday about the Coca-Cola samples. Yes? Yeah, great. We can ask questions about our wine. And then, of course, whatever you're drinking, you're recording in your tissues. And so we can measure your tissues and predict your drinking water and then potentially your origin. So that's sort of the forensic spin to that. Questions on hydrogen and oxygen in beverages?
Wait, can you go back?
Yeah. You want to do the...
You go first. I want to, doesn't this... Sorry, the Rocky Mountain, I mean, it's kind of a big range. It like goes right with the Coors beer.
Mm-hmm. But if they're using the same source every time, I've got 5 different samples that have very, very different values. I wouldn't expect one source to change that much. Across the Rocky Mountains, I might expect to see that much variation. But if you're telling me you're using the same source,
100% Rocky Mountain.
so maybe they're being very careful in their language. And we are interpreting it as the naive consumers that we are, as, oh, you're always doing the same thing every time.
But it also doesn't tell you how much 100% Rocky Mountain spring water goes into.
Oh, that's a good point too. Look at all these semantics. They must have lawyers writing some of this, like helping them. Question?
Have you looked to see if it's the same high country barley?
No, we've done, you'll see some solids, some dry everything down and analyze the solids. You'll see that in a minute, actually. So you're sort of anticipating the next section, which is good. Any other questions?
Yeah. Well, I mean, why do we assume that the water isn't varying in the source if there's a headwater river that's relatively dynamic or something like that? I mean, or groundwater coming.
We like to think when we say the same source that it means the same, but you're right. We are making the assumption that that doesn't cover isotopic change. If it's coming from a spring, though, I don't know that I would expect it. At least in the tap waters that we've been analyzing in cities, we don't see enormous variations, except California. Mike.
That's a huge plunger on that plot. Right? What do the data look like? Are they buying more?
Gabe made that plot.
This doesn't sound to be generous. Those are like every tap water sample we've measured from any state in the Western U.S. basically to see that it's Rocky Mountain. If you go to just Colorado, it's tiny. So the point is that those ones that are sticking way up there at -3 can go like nowhere near Rocky Mountains, right?
Well, I don't know because I can't see the tap water data. I was just seeing a summary.
Gabe will hook you up. I'm so glad the author of this slide was in the audience. Otherwise, I'd be in trouble. Any other questions before we move on to carbon and beverages? Okay, moving on to carbon here. So, oh, no, sorry, one more. We'd already sort of talked about this, so I had put it out of my mind. But this is the idea of, can we double check that you're not from concentrate juice? Your fresh squeezed juice is really fresh squeezed. So this is looking at hydrogen and oxygen of the water in 4 different orange juices. And are any of these reconstituted? The answer is, of course, yes. The ones that are sitting very close are actually on the global New York water line. And so this is actually 100% not from concentrate down to basically a little bit of orange coloring like tang and then pure water. Okay, now we're going to talk about carbon and beverages. So this is looking at sparkling wines purchased in the United States, but coming from different parts of the world. So what you do is you can actually measure 2 sources of carbon. You can look at the CO2 that's in the bubbly, that makes it the bubbly, and then you can dry down a sample and measure all of the solids that are left behind, and that's what these data are. So this is the carbon isotopic composition of what's left behind after you dry down a sample. So it'll be the sugar, the adjuncts, basically the sugars and all the solids that are there. And you can see we've got a nice big range with some stuff that looks very C4 and some that doesn't. So if you make a quick mixing model and you predict how much C4 is in these samples, at times 50% or more of the carbon that was in those sparkling wines came from a C4 sugar. And this was correlated with price. So the cheaper the wine, the more likely you were to have C4 carbon in there. Okay, same idea here with beers this time. So these are purchased in the United States. These are produced domestically, so these are US. These are some North American and then some European beers. Barley should be the main carbon source for these, but if we were using corn instead, of course we'd see more of a C4 signal. And again, probably not surprisingly, the cheaper the beer, the more likely you were to see C4 sugars in there. So here we've used isotopes to look at what's in our beer. Has anyone been to the Desert Edge yet, down at Trolley? These are 2 of their tanks, C4 versus C3. So maybe we don't even need to use isotopes. We can just go to the breweries and take photos of their vats and go, ah, I see what you're using for this one. So that's of course not what they were doing. They just happened. I geeked out so hard when I saw this the first time. I'm like on my iPhone, like, let me take photos. They're like, what are you doing, you weirdo? You see, it says C3 or C4. I didn't even take up a whole hour. That's awesome. I just wanted to end it. I didn't give any reading before this because you guys have been overwhelmed, I'm sure, with reading material. But if you want to know more, here are some really good resources. Sort of the first study that came out that put together a lot of food isotope studies was from 2001. And you can see they're being published up to this year. These sort of nice reviews about how we can use isotopes and in food forensics. And this is your shameless self-promotion alert, but I co-edited a book. And if anyone ever asks you to do this, say no and run away as fast as possible, because this took us 2 years. We co-edited a book on food forensics, and a lot of the figures that you saw in this talk are in there, and it comes out in less than a month, which is really exciting, actually. So that's the shameless self-promotion bit. And with that, I'll end with a picture of all of my toys from my thesis road trips. And you can see that the Shrek movies were really popular at the time. That's why we have a lot of Shrek toys. And I'll take any questions that I haven't already answered.